You found the Backup Wrap Up, your go to podcast for all things backup, recovery, and cyber recovery. In this episode, we're covering Forever Incremental Backup technology and how that completely revolutionized the entire backup industry. Remember the old days of doing weekly fulls that brought your systems to their knees? Well, those days are thankfully gone for most people. We're going to walk through the evolution of from traditional approaches with fulls and incrementals to synthetic fulls and finally to true forever incremental. If you're still doing things the old way, well, you're missing out on some serious benefits, better performance, lower storage costs, and way faster restores. Perhaps this episode will cause you to rethink things a little bit. By the way, if you don't know who I am, I'm W. Curtis Preston, aka Mr. Backup. And I've been passionate about backup and recovery for over 30 years, ever since I had to tell my boss that we had no backups of the production database that we had just lost. I don't want that to happen to you, and that's why I do this. On this podcast, we turn unappreciated backup admins into cyber recovery heroes. This is the Backup Wrap Up. Welcome to the show. Hi, I'm W. Curtis Preston, aka Mr. Backup, and I have with me a guy that I bet is pretty dang happy right now, Prasanna Malaiyandi. Why are you looking like that?
I'm very confused about what I'm happy about.
Really? Do I need to explain recent events that happened at your house?
Oh, yeah. For those of you, by the way, who are listening to this podcast via audio, we also provide video on YouTube. So if you wanted to see our expressions just then and really see what Curtis is laughing about, go check us out on YouTube.
So what events happened in the last 48 hours?
So my wife was in India for visiting family, and she just got back. And so, yes, it was good. And
suddenly you're so much harder to get on the phone. Between that and your new job, I don't even know you anymore. He's like, why would I be happy?
I was thinking, was it something YouTube related? Was it something we had watched or we had talked about? And
no, the fact that your wife is back.
Yes. Although she's also slightly jet lagged. So
well, it's it's 12 hours difference?
I think right now it is 13 and a half.
Yeah. Yeah. So
she does a lot better with jet lag than I do. So anytime I go and come back, it takes me like 3 weeks. And we have a dog, which I think some people have seen on the podcast. And it's funny because he gets jet lagged when I'm jet lagged. So his hours will shift to match with mine. So when I'm up, he would wake up and he would be like, hey, I'm ready. Let's go. And then when I'm passed out, he's asleep. So yeah, he's jet lagged without ever traveling.
Yes, your dog that's named after an Indian dessert.
Ice cream. Yep.
Ice cream. Oh, yeah, ice cream. Yeah, kulfi. Yeah. Which I have now had.
Yeah. And what was did you know they have various flavors of kulfi? They're not all just like one.
Oh, I thought it was all mango. So it's like mango kulfi and then coconut kulfi. What are the other?
They have like cardamom and pistachio, and I think there are other ones too.
Yeah, I don't know. Yeah, I've used cardamom as an ingredient, when I made the mango pie thing, but I don't think I know what it tastes like by itself. So I'll have to sprinkle some and see what that tastes like, or maybe just go and get some.
Next time you're at the Indian store, actually, sometimes even the Costco's carry like a sampler pack of kulfis.
Oh, yeah? So like when I go to the cash and carry down in Mira Mesa.
Yeah, the cash and carry will definitely have it if you go check out their freezer section. Just try not to eat them all before you get home.
Yeah. So, oh man, you're literally like
Is like your my mouth is salivating?
Yeah. Thinking about. Sounds yummy. So we're going to talk about something that's just as yummy. That is, if you're into the backup thing, we're going to talk about Forever Incremental and sort of just how big of a deal that is or was. At this point, it's in most modern backup products that have come out in the last 10 years, I'd say. Ones that are actually new, right? So, when we look at the products like Rubrik, Cohesity, or modern SaaS applications like Druva, Haiku, Keepit, Alcyon, right? All of these products have Forever Incremental in common, right? Nobody wants to do full backups anymore, or anything like full backups, right? So let's talk about that. Let's talk about where were we? What was it like back in the day? And then sort of how we got from there to here, and why it's such a big deal, and why you should care, right? And why this perhaps may give you a reason to finally, what is it? Chuck the mortal coil. What is that? What?
I'm just thinking, are there company, and maybe as we're talking we can figure this out, like, are there still vendors that exist that don't support Forever Incrementals?
That's actually a really good question, and I'm going to say yes. Absolutely.
Yes.
Right? Because my concept of what a true Forever Incremental will be based on like a complete redesign of the underneath, right? Yeah. So the phrase I was looking for is shuffle off the mortal coil of your old backup product. By the way, wait, quick story. So I'm on a plane one time, and this pilot, he was talking about the fact that we were about to take off, and he referred to taking off as shuffling off the mortal coil of this earth. And I'm like, dude, that's a phrase for dying. Why the hell
would you use
why would you do that, right? It's a Shakespeare. It's from the to be or not to be soliloquy in Hamlet.
In all fairness, though, I would say 97% of people probably had no idea what that phrase meant.
They'd never even heard.
Right? Just...
Yeah. And just to since I'm over here quoting Shakespeare, let me just put this up. I'm not a huge Shakespeare person. In fact, it wasn't until, I don't know, several years ago, and we were in England, where I got to actually see my first Shakespeare play, which was Henry V. Some people say Henry V. I think it's actually called Henry V, which is the one with the St. Crispin's Day speech. Once more into the breach, close the wall up with our English dead and all that. But anyway, sorry, I just bored everybody. Sorry, you're asleep. Wake back up. We're going to talk about backup, which is so much more exciting than Shakespeare. All right. So first, let's talk about. Do you want to define?
Let's talk about the old days first.
Yeah, that's what I'm saying. Okay. That's what I'm saying. Do you want to define what a full and an incremental backup is?
Yeah. So normally, when you think about backups, right, typically people talk about fulls, incrementals, right? A full is basically your entire application, data set, whatever it is, everything is backed up. Mm-hmm. And then between doing every fulls, you would do incrementals, which are just the things that have changed since that last full. And right. So you do these periodically, and normally you do incrementals because they will be smaller, right? So you could say do a full once a week and then incrementals during the week, such that you can finish in time or during your backup window. And then the next weekend you would do like another full, right?
Right. Now I'll slightly change your definition or append or whatever. So you specifically described what I would call a cumulative incremental, yes. Right? So what is referred to as a sort of a regular incremental or a differential incremental.
Yep.
Is one where it's the changes just since the last incremental or since the last backup of any kind.
Yep.
Right.
And then you could talk about backup levels and all the rest.
Yeah.
And it gets very, very complicated, and you can look at those. But at a high level, there are those three types, if you will.
Yeah. And then what it really came down to is how things behaved when it came time for a restore. Mm-hmm. Right. So if you were going to restore something, then you needed the latest cumulative incremental, if you were doing such a thing, and then any incrementals since that day.
Yeah.
And so those of us, I remember at some point, we used to do weekly fulls. I remember my preferred backup design switching to monthly fulls, weekly cumulative incrementals, and then daily incrementals. So if you were, let's say, 3 weeks into the month, you would need the full from the first of the month, the latest weekly cumulative incremental, and then 3 or 4 days worth of incrementals, and in order to do a restore. So what it meant was that you would often, the way the restore worked is you would restore everything that was in the full, then you would restore everything that was in the cumulative incremental, and then you would restore everything that was in each of the incrementals. What that meant was there were many files that you were actually restoring multiple times.
Yep.
And you were overwriting them, which was just inefficient.
Yeah.
And what that also meant was that you had duplicate data. The old way of doing backups created a ton of duplicate data on the tapes.
You could say duplicate, or you could also say it's independent, depending on the glass half full, glass half empty.
Well, so no, I understand what you're saying. What I'm talking about is the fulls.
Yeah.
The fulls over time created a ton of duplicate data.
That's true.
Right? I know what you're thinking. You're talking about within the incrementals. I'm mainly talking about how many different copies of the exact same file were all over, everywhere.
Yeah, and especially because most times, right, you look at sort of like a 2% daily change rate, which maybe translates to like a 7 or 8% change rate per week. And if you're doing those weekly cumulatives or even the monthly fulls, right, you're basically backing up a bunch of data which you don't necessarily need, that haven't changed.
Right. The reason we did it the way we did it wasn't so much about independence. It was about minimize. So if you did a monthly full followed by nothing but regular incrementals, you would have to load 30 tapes at the end of the day, right? At the end of it. And even if it wasn't tapes, you have to do 30 restores.
Yeah.
So the differential or the cumulative incremental was about minimizing the level of effort during a restore. Right. And then came along this thing called dedupe, which at least helped minimize, I think, all of that duplicate data.
Yeah, because I think with deduplication, it was nice because you didn't have to change what you were doing from like a policy perspective or a scheduling perspective, but you got, like you said, it was able to dedupe, of course, the data in the back end and save you the storage cost.
And that's why if you were doing a typical weekly, by the way, nobody did the monthly full thing that I recommended. Most people did weekly fulls, right? And so when you had weekly fulls, this is why, and you had like 90-day retention. This is why just with even crappy dedupe, you got 20-to-1 data reduction, right? And this is what helped pay for what helped created the market for all that dedupe work, right? And then we could argue over we're 20-to-1, we're 30-to-1, we're whatever, right? And we save this much more money. Once you get rid of all those fulls, everything else was really kind of incremental. But I think the real challenge was just the core backup design of when we go to do a restore, we have to restore data multiple times, right? It just simply wasn't efficient.
Well, and I think even before we get there, I'd like to cover just one point, which is even if you had the existing backup schedule, right, where I'm still doing weekly fulls and daily incrementals, you're still transferring all that data over the network, right? And I think this is where client-side deduplication would probably come next, in my opinion, right, where it would help you reduce the amount of data you're actually sending over the network, right? And that'll help save you cost as well as time.
Yeah, that's actually a really good point. Thanks for bringing that up. So one of the other, like basically what you're saying, that one of the other downsides to doing it the old way was both the transfer across the network as well as the impact to the clients.
Yep.
Right? If you're doing a full on a regular basis, you're there's a cost to that in both, you brought up bandwidth. It's bandwidth, storage, and compute, right? It's like all the things. There was also a sort of a perfect storm brewing. So we're doing fulls on a regular basis. We're doing cumulative incrementals on a regular basis. And this is how we were doing things. And then along came virtualization. Why was that a problem?
Well, because a lot of the data was all the same, right? When you look across all of your VMs, they're probably spun up from the same golden copy, right, of your image.
Well,
and there's a lot of commonality amongst them.
Well, this is another example of that's a great answer. It's not the question I was asking.
It's also shared resource on the back end because you're now
that's what I was going after.
The storage and the compute, right? You don't have your own dedicated instance.
Yeah, that's what I was going after, right? So that was a real problem when VMware got really popular and we just kept doing the same old thing. Because remember, for a long time, we backed up VMware, we backed up the virtual machines just like they were physical machines.
Guest-based.
Yes, guest-based. We just basically installed an agent in every guest, and that's how we did the backups. And, and what happened was just randomly, you'd end up doing a bunch of fulls at the same time, which worked fine when we were 20 individual machines, but now we're 20 VMs all on the same physical machine. And that just broke, virtualization just broke backup overnight, right? The latest thing to break backup overnight is containers.
Yep.
Right? That's a whole other thing. We're not talking about that right now. But
And so I think, though, this is what sort of caused VMware, right, plus the backup vendors to figure out, is there something better we can do in order to help satisfy backup needs? Because it's not going away, right? You have to back up your VMs.
Right. So the real key, I think the real goal, like if we could go back in time, and I don't know. This is one of those things where I don't know if I wasn't in the rooms, right, when they were designing this stuff, but I'd like to think that somebody said, because my memory is we had issues with tape, right? There was the fundamental mismatch of speed tape. People thought it was slow. It was actually fast. And that was a problem. And so we started doing disk staging. We started doing disk backups because of that, right? And then dedupe came along, and dedupe said, hey, we can make disk better. We can make disk, more affordable. And so that was, and then it just sort of happened. But even if that wasn't the case, I think the design of backups ultimately ending up being what we're talking about today, which is Forever Incremental, it accomplishes multiple purposes. One is it solves the issues that we have with tape, because in order for Forever Incremental work, you've got to be using disk, right? For true Forever Incremental work to work, you've got to be using disk. And then the other thing is that it solves the cost issues, it solves the performance issues for restore. It does a lot of things.
Well,
right?
why don't you first define what Forever Incremental is? Because I
don't want to. Well, before we get to Forever Incremental, we got to talk about something that was a stopgap technology to get from. We wanted to get to a point where we weren't doing fulls anymore. Mm-hmm. Everybody agreed that fulls stunk, especially when we're talking about virtualization, right? What was the stopgap technology that backup vendors came out with before we went to the whole forever incremental?
They created what they called synthetic fulls, which is basically you are creating a full on the back end, but you're sending data and stitching it together and piecing it together to make it look like what the full would look like, because you know what the previous backups were on that system.
Right. So it's like we already know what the files are in the full, because we did another incremental.
Yeah.
So we know what's deleted, we know what's new, we know what a full would look like if we went and made one. Why don't we just make one over here without having to do it over there? And there were a couple of different ways to do that. There was the backup vendor way, and there was the backup software vendor way, and then there was the backup hardware vendor way. I'll talk about the backup software vendor way first. It's like, we know what all the files should be on a full. We know where all of them are. We're just going to copy them all together, in one image, and then we're going to copy that over to a new set of tapes or a new set of disk. So that we essentially create an actual full without actually having to transfer any data around the network. It might be transferring it. It is transferring it within the backup system, right? And then there was and that took a certain amount of time, right? And then a vendor that you might be familiar with came out with a different way to do it. What was that?
Yeah, and basically, they basically said, just tell us how you want to stitch everything together, and we'll stitch it all together.
Yeah. So it was like an API, right? You know where all the stuff is. We have all the stuff. Just tell us which stuff you want where, and we'll go. And so they could make essentially a new full, when in reality it's just a bunch of pointers to what was already there, right?
And this works.
And it was really
well.
quick, right?
Yeah, it was really quick, because the key is, especially on a deduplicated system, you're not actually copying the data. It's all pointer manipulation.
Right.
So you're not actually moving any data. You're just changing metadata, which is very quick, very fast.
That was a great singing group from the 90s.
What? Metadata?
Pointer manipulation.
Oh.
But anyway, so that was sort of a stopgap solution. It allowed people to stop doing real fulls, solve the issue of the load on the client, solve the issue of the load on the network, but we were still creating fulls. So the concept of forever incremental and true forever incremental is that we first have to design a backup product that just no longer needs repeated fulls, right? And by the way, this generally does only apply to file system backups for the most part, not database and application backups. Most of them still require repeated fulls. Some of them have forever incremental, but
I would also say, or would you also say, for virtualized workloads this also applies?
You mean the backup of the system itself? Yeah. Yes. So if I was to use a term that would apply to to both of them, I'd say volume-based backups, right? So either a file system or like a VMDK file or a VDK file, right? And the idea is that we're just going to do one full, and then we're generally going to be doing block level incremental backups, not just incremental, but block level incremental. What's the difference between those?
Well, a block level incremental allows you to look at changes within a specific object. As an example, say you had a 10 gigabyte PST file representing your email, and instead of doing a normal incremental, which would transfer the entire 10 gig file over when you back it up, using traditional incrementals, a block level incremental would just take the changes within that 10 gig PST file and transfer that over.
Exactly. And so it's another data reduction technology like deduplication, and I think it was an order of magnitude reduction in the number of bytes that has to be transferred. And the way this worked in file system backups was that you had to have like an API into the actual blocks, the disks, right? Which was somewhat problematic. The easier way to get this was in the virtualization world, where you had an API, right? Like the change block tracking API, where that you can the backup app can just say to the virtualization vendor, hey, I'm here to back up again. Just give me a pointer to all of the blocks that have changed since the last time I was here.
Yep.
And then we can transfer just those changed blocks. But more importantly, for a true forever incremental, for me to think that it's a truly forever incremental, is that you're going to change how the data is stored on the back end. So there really isn't a concept of full, right? The way that you're storing each new backup is that each new backup from a restore perspective behaves like a full.
Yeah.
Right? You want to put that in?
Yeah.
Go ahead.
So I was just going to put it in my own words, which was basically you're able to send only the changes and end up with the full on the back end, such that because each one is a full, they can be independently restored without any dependencies on others.
Yeah. So you don't have this idea of restoring the full and restoring the incrementals individually, right? You just restore the late, it's sort of like take what we used to do, take the synthetic full. Every time we do an incremental, we're essentially creating a new synthetic full.
Yep.
How's that?
Yep. And because if you think about it, it's just kind of changing where the processing happened. Right. Because with synthetic fulls, the client was telling the storage, okay, these are the pieces I want you to stitch together. And it might have been pieces across multiple different backups. Mm-hmm. Right. In the case of an incremental forever, it's like, hey, your last backup, go apply these changes on top of that last backup. Yeah. At the right offsets.
Right. Go ahead.
But it needs to be a system that allows you to keep those copies as independent.
What do you mean by that?
So, some backup technologies which claim to be incremental forever, right? Mm-hmm. They only keep the latest copy. Right? So, for instance, you have a full, you apply the changes, you now get a new full. That old full is gone from the system. Right? You only have the most recent copy. Right. And normally for backup, because you want to be able to go back further in time, you need to make sure you are preserving those previous copies as well. And so it might require a technology like deduplication, which allows you to efficiently store multiple copies, snapshots, whatever technology is available on the back end in order to make that possible.
Yeah. So snapshots and replication, a great example of forever incremental technology, right? Yeah. Each time you do a snapshot and a replication, you get a new something that looks like a full, when really all you only transferred was the bytes that have changed. Yeah. And then I can immediately think of when you were talking, I was like, what is he talking about? And then I realized what you were talking about. So here's an example of forever incremental that isn't what we're talking about, and that's replication. Yeah. Right? Just regular replication without anything beside it. You end up with every time you do if you want to call it that, an incremental backup, all you're left with is the latest version, and you can't go back in time.
Yep.
Right?
You know what I was actually thinking of when I made those comments?
Oh, what were you?
Oracle incremental merge.
Oh, okay.
Because Oracle incremental merge applies the changes on top of a full, but it does not preserve the previous versions.
Right. Yeah, that's a good point. Which wouldn't that's really just a type of synthetic full, right?
Yeah.
Yeah. I didn't even realize that, by the way. So how do you preserve the history?
That's why you need an application or a storage system that allows you to take snapshots. Or a copy of the file before it gets applied. Why do I know these things, Curtis? Why do I still remember these things?
It's why you're here.
So we've defined what a forever incremental is. We talked a little bit about the benefits, right?
Yeah.
Being able to quickly restore because you have the full copy, being independent, not having to transfer all the data, right?
Right.
Can you
and also cost savings,
Yeah.
right? Right. Yeah.
Can you think of any cons?
Well, the only thing, one of the things I said in the beginning was that in order to do forever incremental successfully, you've got to store the data on disk. And again, not to be, pro tape and all that stuff, but we did an episode relatively recently where we talked about how you have to protect the backup disk. The only con that I can think of is that your entire backup is just sitting there ready to be attacked, right?
Yeah. I have a con.
Go ahead. You have a con?
I do. So having worked with vendors, and I'm not saying this has happened, but it is a potential thing you should think about, is when you have forever incrementals, right? You're always copying over the existing backup every time. If there's a software bug that somehow that corrupts a part of your backup, right? You've now impacted how many versions back because you're never getting a full copy of that data again, right? It's always incremental.
Right.
And
right.
so that could potentially be one of the cons of a forever incremental approach.
That was a critique of dedupe because it has the same issue, a critique of dedupe when dedupe first came out. And all you can say is that you just do your best to ensure that that's not happening, and that's why we do fingerprinting and integrity checks and all that kind of stuff.
And also test your backup.
Yes, and also test your backups, right? Yeah. Test your backup, test your backup, test your backups. But go ahead.
I do have another one too, unless you want to.
Oh, you do? Okay, go ahead.
The other one I also wanted to mention is, right, if forever incremental backups are so great, why isn't everyone using it? And I think one of the challenges is it requires vendor support, right? So the application to support it. So VMware supported it for virtualization, right? Other companies support it for their own applications, but not everyone supports it. Not everyone makes it available, right?
Yeah.
And so you sort of are limited in terms of what applications, what APIs are available, and can you get the changes that you need in order to be able to create your forever incremental in the back end.
Exactly. And I can think of modern database applications that do support it, right? I can think, for example, when you back up Salesforce, right? You're backing up at the object level, and it's very easy to, and let me rephrase that, because Salesforce uses the term object to mean something very different than what we mean. Because why should we all use the same terms?
Of course.
A Salesforce object is like the user's table, right? So I'm talking about like I made an update to a field in a record in a table, and you can back up that change as right, and you can do it incrementally or you can do it independently. And so it would be very easy to store all of those objects in a way that would foster this idea of a forever incremental. Whereas like Oracle, for example, there really isn't a way to do it. At best, what we can get out of Oracle is the concept of a synthetic full, and the synthetic full that they have has the issue that you mentioned before. Whereas once you do the synthetic full, you don't have the previous incrementals. So yeah, that is definitely it requires your backup vendors to support it, and it requires your application vendors to support it.
Yeah,
absolutely. I can't remember where I was going before you brought up that other. I will say this, that the title of this is, how forever incremental backup changed the world. It really has, right? The idea when you look at these modern backup products, the idea of doing a full backup is just gone, right? All of the downsides to doing a regular full backup are gone. The compute considerations, the network considerations, the storage considerations, they're all gone without any negative like impact to the restore. In fact, it's the opposite. The restore is now, since we know what a full looks like, when we go to do the restore, that is to harken back to the original way we did restores, we're no longer restoring the same file multiple times during a single restore. Why would we do that? We know where all the files are. We know where all the blocks are. Whatever it is that we're restoring, we know what the latest version of that block or file is, and we're just going to restore that one. I have a story. How you do Forever Incremental matters. The original, the OG Forever Incremental product is TSM, right? And the way it was implemented back then was to tape. And they tried to bring this concept of Forever Incremental to the world without changing the underlying storage technology, because back then it was if you brought disk into it, it was crazy talk, right? So they can get a lot of credit for trying to accomplish this idea, but I still think when we look back to TSM of old, I think it was a failed attempt, because my earlier statement of the only proper way to do Forever Incremental is to do it on disk. When they were doing it on tape, what it meant was that when you went to go to do a restore, the full was on like 5,700 tapes.
That sounds worse than just doing your traditional fulls and incrementals.
Yeah, well, it was, and I remember doing there was one particular restore that I remember doing using TSM in a production environment, and I don't remember the actual numbers, but I'll just use fake numbers just to describe what it was like. It was like we were doing like a 10 gigabyte restore, and it took like 2 weeks because of how many hundreds of tapes. That it was thousands of tapes.
Yeah.
Because of the number of files, the number of tapes that they were on, and how long it takes to load and unload an individual tape, right? Yeah. And they had technologies called reclamation, and they had a number of technologies that tried to minimize this issue, but
it still existed.
Well, yeah, it still existed, and also some people, they would run out of time in the day to do reclamation. Reclamation is where you take a bunch of tapes that that most of the files on those tapes were no longer needed because they'd expired, and then you've got a bunch of files that are 10%, and then you copy them to one tape.
It's like garbage collection.
Now 100%. It's like garbage collection, but on tape.
Yeah.
And it was a very labor-intensive process and I/O intensive process, and as a result, it took a long time. And so some people would turn it off, and I think that's what happened in this case. And so there were literally just, I don't remember, there were so many tapes that we had to restore. And it sounds like I'm bagging on TSM. TSM is still around. It's now called Spectrum Protect. But the addition of bringing in disk, I think, makes this whole issue kind of not a big deal.
Yeah.
But yeah, I still think that you look at all of the modern backup products that have come out in the last 10 plus years, and they're all like this. They're all one full followed by a whole bunch of incrementals, and the world is a better place for it. And you young whippersnappers that never had to deal with
tape,
full and incremental backups, you just don't know what
pain.
You don't know the pain that you had. It's funny, this morning I was hanging out with some people and I was talking to them, and it's this lady who shares my birthday, but she's about 15 years older than me. And we started talking about all of the technology that we remember when it came out, right? And the first piece of technology I remember being introduced in my life was the VCR. And it came, I remember them wheeling one into the classroom in my school, and it was gigantic, right? It was and it was the kind where you put the tape in and push it down, right? Yeah. anyway, this is like that. This is like the way we did backups. And by the way, I'm glad I remembered this, because you asked a question earlier. Why is it that not everybody does things in this new way? Because backup is the stickiest application in the data center.
Yep.
So many people are still using the same backup application that they were 15 years ago. Some people change their applications like they change their underwear.
Yeah.
But other people, it's a pain. It's costly. It's risk. It's fraught with risk and difficulty and a giant learning curve. And during that learning curve, your data's at risk.
Yeah.
And so most people they'd rather stick with the ugly, old backup product.
Don't break it.
Because it works, yeah. And so it gave birth to incrementally helpful technologies like deduplication. Don't change anything.
Yep.
Just send your backups over here instead of sending your backups over there, and we'll get rid of the duplicates, and we'll make it sort of look like an incremental forever, but just keep doing it the dumb old way.
Yeah.
Because we don't want you to have to change your backup product in order to get to. And I guess this is, if you're one of those people that's still using the same backup product that you had 15 years ago, and you're still using it the same way you were using it 15 years ago, and you're not using incremental forever as a true technology in your world, maybe time to think about it.
But I would probably say newer workloads, people are probably using that, right? Because once again, environments are a mishmash of technologies, right? And so people probably do have those old databases, old applications, which they are using an old infrastructure, backup infrastructure for, and for their virtualization or other newer workloads, they're probably using something different.
Yeah. Remember I did that survey a few months ago, and I asked them how many backup apps they had, and 30% had I think more than 30% had 3 or more backup apps in their environment. Yeah. And it's because of what you're talking about. They start using containers, and their current backup app doesn't know what to do, and so they use that for the new technology. Yeah, that's very common. And I guess what I'm saying is maybe it's time to check out the water of truly incremental backups and experience all the beauty. Yeah. All right. Well, thanks for the chat again.
Anytime, Curtis. Anytime.
All right. And we want to thank our listeners. You're why we're here. Otherwise just two guys sitting here talking over a couple of microphones. That is a wrap. The Backup Wrap-Up is written, recorded, and produced by me, W. Curtis Preston. If you need backup or DR consulting, content generation, or expert witness work, check out backupcentral.com. You can also find links for my O'Reilly books on the same website. Remember, this is an independent podcast, and any opinions that you hear are those of the speaker and not necessarily an employer. Thanks for listening.